everyone, and welcome to lesson 10.4, day 1. Today we are going to start talking about inscribed angles. And what is an inscribed angle? Well, an inscribed angle is an angle whose vertex is on the circle and the sides contain chords of the circle. So we have an inscribed angle here, angle ABC, whose vertex is on the circle, and our inscribed angle's measure is half of the measure of the arc it intercepts. So for instance, if we know this arc right here, AC is 60 degrees, then angle ABC is going to be half of that, 30 degrees. And on the contrary, if we have the angle given, we know that we need to double that angle to get what your arc would be. So if angle ABC is 40, we know we can double that to be 80 then for the measure of our arc. Now, this is also going to work for other types of angles on the circle besides our inscribed angles. So we see some examples of inscribed angles in these first three. And again, we know that the measure of the angle is going to be half of the arc, or we can double that angle measurement and it will equal the arc, right? That's also going to play for angles that are just on the circle that aren't necessarily inscribed. So notice this one being made up of a tangent and a chord. This angle that is on the circle, again, that vertex here, notice it is opening up onto arc BCD. So again, it is going to be half the measure of that arc would be the measure of angle ABD. Or we can double that angle that is on the circle and it will equal the measure of that arc it's opening up onto. So on the next page, if you flip it over, we see some examples of this. Again, we are looking for the measure of angle SRT here. So we know that is going to be half of our arc it is intercepting, so 55 degrees. On the flip side, we are looking for the measure of R to Q. So we would double 80 degrees to get our arc there, 160. Now on this next one, notice we are looking for arc RP over here. When we look at where our inscribed angle is opening up to, it's opening up onto arc PQ. So we know that the arc PQ is 200. We're given that arc RQ is 71. So to find the measure of our missing arc here, we can take 360 and subtract away the two arcs that we do have to get our remaining arc measurement of 89. Down in example D, we are looking for the measure of angle BAD, again, an angle on our circle. So it is going to be, again, half the measure of that arc it is opening up onto, in this case, BD. So half of 124 would give us an angle measurement of 62 degrees. And then over on the other one, we are actually given the angle and we want the measure of that arc it is on. So again, this angle is on the circle and we are opening up onto arc AEB. So we would double that to get the measurement of 266 for our arc on the circle. Down below, we have a couple you try questions. The first one is asking you for the measure of XWY. The second one is asking you for the, given the measure of angle KLJ, you want the measure of your arc. And then finally, they are giving you the measure of angle ECB. You are trying to find the measure then of the arc CB. Our next key concept of the day is looking at the fact that when we have these two inscribed angles opening up onto the same arc, so notice both of these open up onto the same arc, what we know is that those angles are going to be congruent to each other. They're going to have to be the exact same size. So in this case, angle D is congruent to angle C. Now, sometimes what we notice then is that we are given some different arc measurements around the circle, and we want to find other missing angles. So we have some arcs given. We have A to B is 140. We have B to C is 100 degrees. And then they're telling us that AD and DC are the same size. So these two are going to be congruent arcs, whatever they may be. So we can take our calculator and find those measurements because we know that two of those arcs are 140 and 100. And then we know that they're being divided up evenly between those two arcs. So each would end up being 60 degrees. Now that we have those arcs around the circle, we can start looking for our angle measurements. So angle 1 is right here. And notice this is opening up onto our 60-degree arc is what it's intercepting. So we're going to take half of that 60-degree arc to get that angle on the circle of 30 degrees. Angle 2 is over here. We trace that out. Again, it's another one where we're taking half of a 60-degree arc, so it would be 30 degrees for the angle. And then angle 3 is right here. It opens up onto this 100-degree arc, so half of 100 would give us 50 degrees. Last two then, as we trace it out, angle 4 opens up onto this 140-degree arc, so half of 140 is 70 degrees. And then last but not least, angle 5 is right here. Angle 5 opens up onto the 100-degree arc as well. Half of 100 would be 50. So I highly recommend tracing out so you can see where your angles open up onto. On the back, we have another example. We are looking for the measure of angle CFE. So this question mark here. Notice this is opening up onto officially two arcs that are being given, 74 and 68. Well, if we add 74 and 68, we see that that whole arc together would be 142. And our angle then is going to be half of that 142-degree measurement. So it's going to be 71 degrees. On this next one, they are giving us the measure of angle MFK. And so we know that this whole arc it's going to open up onto is going to be double the measure of that angle on the circle, right? That inscribed angle. So 248 is the measure of this whole arc. Now, we also know part of this arc from M to L is given to us as just 167. So if we take 248 minus the 167, that remaining arc over here, L to K, which is what they're asking us for, would have to be 81 degrees. Two examples for you to try now over here. They want you to find the measure of angle DYB. And you are given the angle RDP. You are looking to find eventually P to Q. All right, our last key concept then is talking about our angles that are inscribed on the circle. If we have an angle or part of a triangle that it opens up and it intercepts a semicircle, we know specifically that that angle has to be a right angle. So for instance, if we know that angle ADC is a semicircle and measures 180 degrees, this angle on the circle that opens up to that has to be half of that, has to be 90. So down below, if we look at this picture, we know that angle PQR is opening up onto arc PAR. So arc PAR is 180 degrees, and then this angle on the circle would have to be half of that, 90 degrees. Now we want to look in part B, is angle GHF a right angle? Well, notice our piece here, GF, is not a diameter, right? It's not passing through the center of our circle. So it's not a diameter, which means that the angle is not opening up onto a diameter or a semicircle, right? So it's not a diameter. So thus, this is not going to be a right angle. Down below, you want to check out those examples, okay? You want to check out, is CNM a right angle? And you want to check out, is EDC a right angle? So again, you're checking, do they create semicircles? Thanks everyone for watching. We'll work more with these in class.